Hi everyone, I hope I'm audible and visible to all of you. Could one of you give me a quick yes if you can see and hear me? Hi, good morning. Just give me a quick yes so I know I'm audible and visible to all of you, and then we'll start off in a minute or so. Awesome. Great. All of you can see and hear. Awesome. So, welcome to the first session of the blockchain engineering program. And to make it easy for you guys to study this course, I've created a blockchain engineering playbook, which probably you can see the cover on your screen right now. And let me just quickly go through the book. So the first thing that you notice on the first page is that there are three groups that I've created on WhatsApp for people doing this course. So because WhatsApp puts a limit on the number of people who can join a group, I've had to create three of them. If all three get full in due time, I'll probably create a fourth one. But more importantly, there's also an official LinkedIn group for this course, and this is the URL. So there are about 11,000 people already in the group. So I strongly recommend that you guys all join this particular group, because even if you're not able to join the WhatsApp groups, make sure you're in the LinkedIn group. I'll also be posting updates regularly. And finally, there's also a newsletter called the Blockchain Newsletter. And all the information, if you want it by email, you'll be able to get it through the newsletter. So I strongly recommend you join one of the WhatsApp groups, the LinkedIn group, and the newsletter. Let me see some of the questions before I start. Someone wants to know, is it freely available? Yes, absolutely. It's a free course. So don't worry about that. Now, if you look at the contents for this particular playbook, so we are going to start off with blockchain basics. That's something we are going to discuss today also. And then we are going to go on to something called network security and privacy. Then node maintenance and performance optimization. So please remember, this is not a course towards developer. So I'm not teaching you to become a blockchain developer. So we're not going to do much of coding. We are going to look at it from an engineering, node maintenance, node security point of view. Then we're going to go into Bitcoin and we'll see how to set up Bitcoin nodes, similar for Ethereum. Then we're going to use multi-chain. Now, many people get confused with the name multi-chain because that's used for many different projects, right? So the multi-chain I'm talking about here is a framework which is a fork of Bitcoin Core and which is used to create permissioned blockchains. So you're going to create your own permission blockchain using multi-chain. Then we're going to create assets, do transactions, atomic exchange, and lots of really fun stuff. Then there's a quick overview of Hyperledger, which is again an open source project by the Linux Foundation. And there are lots of very interesting tools and frameworks in that. Then moving on to some chat GPT super prompt templates. So chat GPT can be very useful for us also. So I'll give you some of the templates which you can use to help you in your day-to-day work as a blockchain engineer. Then I've made a bunch of interview questions. So if you're going for an interview to become a blockchain engineer, usually those are the kind of questions you'll be asked. And it's also useful if some of you are actually going to be hiring blockchain engineers, so you can also use these questions. Then there are some quiz questions with their answers to help you to check your learning. So this book I will be posting after the session on the WhatsApp groups. So you can just download from there. I'll put it on the LinkedIn group also, so all of you can access the book. If you have any kind of questions, you can keep posting them and I'll take them from time to time. Right. So now let me just stop sharing for a second. Okay. Now, the first thing I want to talk to you about is that we say that blockchains are internets of value. Now, why do we really say that, and what do we mean by it? When we look at the conventional internet, it allows or enables the movement of data across the globe in seconds or milliseconds. So, right now, when you're listening to me, you're looking at this video, it's a live stream. So, using all the internet protocols like TCP/IP, FTP, HTTP, so many of them, video, text, audio, all that can be streamed across the globe in seconds, right? But when we use a blockchain, we are able to move value across the globe again in milliseconds. Now, what do we mean by that? Now, that value could be a cryptocurrency like Bitcoin or Monero, or it could be tokenized versions of real world assets. So, for example, if someone was to tokenize a piece of real estate, and whoever gets the blockchain token backed by this real estate, well, that token represents value. It represents that real estate, and the blockchain would enable people to buy, sell, and hold these tokens. And that's why we say that blockchains are internets of value and not just internets of data, right? So, hope that part's clear to you. Now, let me go on to something very interesting. When we talk about blockchains, the first thing that we need to understand is a node. Just give me a quick yes if you guys are able to see this image on your screen, right? It should say applications and UI on the top left. Just give me a quick yes if it's visible to all of you. Yeah. Okay, I'm presuming you guys can. Yeah, awesome. So there is a slight lag, so it takes a few seconds for me to get your response. Okay. Now, a blockchain is going to be a connection of nodes. Now, what is a node? A node is something you could set up even on your laptop, or you could use a cloud server, or you could use a physical server, right? Fundamentally, from a concept point of view, we can divide a node into layers. So, right at the bottom would be a hardened operating system. So, blockchains do not have their own operating systems. You need to run them on Linux, Windows, or Mac, depending upon which all an individual blockchain supports, right? Now, that particular operating system that we are going to set up, and we are going to do that practically later, needs to be hardened, which means it needs to have firewalls in place, it needs to have certain accounts blocked, so we usually will not, for example, use the root account for this. So we need to secure this particular operating system. There is a lot of misconception when people say that a blockchain cannot be hacked. Well, that's not technically true. Blockchains do get hacked from time to time, but more important, what usually gets hacked is that operating system on which a blockchain node is running. So that's the first step that we need to take care of, that whatever is the OS we are going to use, it is properly secured. Now, once we put that operating system, the next step would be to run the framework and to install the blockchain, right? So now, for example, if we were to take Bitcoin, Ethereum, any of these, they're open source softwares also. So I could download the Bitcoin software and actually install it and run my own version of Bitcoin if I wanted, or I would run the Bitcoin core and connect to the existing Bitcoin network. So those options are available to me, and that's usually what we say is the second layer in the concept. Then, of course, we have the keys and the assets. So private keys are going to be stored there. So we can choose to keep our keys on the server, or we can keep the private keys off the server. Both options are available to us. Usually these keys use an algorithm called ECDSA, elliptical curve digital signature algorithm. Then tokens, coins, all of that runs at that layer. Then we have the API layer. Now that is where programmers would integrate the blockchain into their software or wallets or dApps or whatever they're building. That would happen through the API layer, which is supported by the blockchain. And then finally, we say that we have the application or the UI layer, which could be web or mobile applications. So from a concept point of view, these are the layers of a blockchain node. If there are any questions, I'll take them now. Okay, so one of the questions I'll take right now is what is multi-chain? So multi-chain is a software framework which we can download, it's open source, and we can use it to create our own private or permissioned blockchains. Any other questions? Just put them in, otherwise I'll go to the next diagram. Give me a second. Okay. Now, this is very, very important for us to understand that now that we know what a node is, so what is a blockchain network actually? So if you see on your screen right now in the center, you see this red band kind of thing in which I've written addresses, ledger, and data. So when we say blockchain, we actually mean blockchain network. So there is a network of nodes. So here on your screen, if you look at these images, so these presume all of them are representing nodes. These could be running on a laptop, they could be running on a physical server, they could be running on a cloud server. Each of them has those concepts that I spoke to you about. So we presume that there is an operating system running there, and the blockchain software has also been installed on that. So some of the nodes could be running Windows, some running Mac, some running Linux. They all come together and they connect to each other. There is no centralized server here because blockchains are decentralized in that fashion. So there are hundreds of such nodes, and presume that they are all connected to each other, although from time to time certain nodes go down, so they may not be connected to the others. Now, at the core, the most important aspect is going to be these addresses, the ledger, and the actual data. So we can say that is the state of the blockchain. Every entity can come and create multiple addresses. So creating addresses on blockchains is very, very easy. We'll learn how to do that later. So whenever you create an address, it automatically comes with its own public key, private key. And the address is somewhat like, you could say it's like your bank account. And when someone wants to transfer to you a token or an asset, they would need your address. Just like say you're in India and you use UPI. So when someone wants to send money to you, they just need your UPI address. So for example, mine is Rohas at Axis. So that's all you need to know to send money to me, and it'll go into my bank account. So similarly, we need to know your address to actually send you tokens. Now, all the transactions that are taking place, they are what we call as the ledger. Because ultimately in a blockchain, we are talking about transactions. So some address sends some token to some other address at a particular date and time. So those addresses, the amount of tokens, date time, all that goes into the ledger. Then you have the data. So the blockchain can also have metadata, which describes transactions. Depending upon the chain, you may also be able to upload data like images, PDF files, and all, depending on the kind of blockchain that you're using. That is actually, this red part is the most critical part. And every node which connects is responsible for doing something to that. So the node could hold all this data, or the node could be pushing information. So we have different types of nodes, and depending upon the type of node, some nodes may hold all the information, some may hold limited information. Some nodes are there only to make transactions faster. So for example, if you've heard that in the country of El Salvador, Bitcoin has been made legal tender, which means you walk into a McDonald's there and you can pay for a burger using Bitcoin. But we know Bitcoin transactions are costly and they are slow. So how is it going to work in a practical scenario where you're buying burgers and say McDonald's is selling 100 burgers an hour? So there's something called Lightning Network. So that runs Lightning nodes. Those are special nodes that make blockchain transactions faster. Then there are cold nodes which are not even connected to the internet. So you can make the transaction there and then broadcast it through another node. So there are many different kinds of blockchain nodes, and all of that is there in the blockchain engineering playbook, which you're going to study later. Let me just see if there are any questions. Okay, I can see some interesting questions. Let me take them on. So there's a question which says, what layer will we cover in this course? Okay, so we are basically going to do L1 blockchains, so layer 1. So in the playbook, I've explained all the different layers. So there is layer 0, which you can kind of consider like Polkadot, which enables you to create fully functional blockchains, which is called layer 1. So a layer 1 is a fully functional blockchain, which on its own is capable of doing transactions and keeping the state and consensus, and the security, everything is taken care of. So you could use Polkadot to spin up multiple such things. So then those things that you spin up are called layer 1. So when we use multi-chain to create a permissioned blockchain, that's a layer 1. Bitcoin, layer 1. Ethereum, layer 1. Then there are layer 2s on top. So for Bitcoin, Lightning Network is a layer 2. For Ethereum, Polygon would be a layer 2. So they come into the picture to make transactions faster and cheaper. And then we could, those are usually the kinds of layers that we see. But in this course, we are going to stick to layer 1. So next question, layer 1, layer 2 difference I've explained. Let's take another question. Does Node always run a web layer and apps? No, not necessary at all. So that's as an example. So you could, for example, run a node, and in that node itself, you're running the API service and you're running the UI, or you would put that on a separate server. So both options are open to you. Usually we use separate servers, right? What I'll take one more question. How do the nodes get discovered and join the blockchain node? Yeah, so that is something, the broadcasting system for that is kind of what the blockchain software takes care of. So that's something we'll see a little later. Uh, one more. Can you explain what is blockchain layer? So, like I said, layer is is like a concept, you could say. So, when a particular blockchain is able to handle the consensus on its own, we say that's a layer one. Then, if the blockchain is made faster by some other software like Polygon connecting to Ethereum, for example, so it's like running on top of that. So instead of every transaction hitting the main layer one, transactions get bundled in the layer two and then they get pegged into layer one. In that case, we call that as a layer two. I hope that's clear, but don't worry, it'll get clearer as we go further down the course. Right now, someone wants to know what architecture means. I'm not understanding your question. So could you just clarify what you mean by this term? What do you want to know about architecture? Right? Now, now that we've understood this red patch, now we can see that there are different kinds of servers here. So now if it was a permissioned blockchain, then there would be administrator nodes. Because what do we mean by permission? That means you need permission to actually connect. So nobody can just come and start running a node. That's okay in permissionless, where Bitcoin, Ethereum, anybody can start running nodes. But when we talk about permission nodes, which is what enterprises and corporates use, we have admin nodes who control permissions and they allow you to connect. And if they want, they can remove you from the network. Plus, each address on a permission blockchain can have different levels of permission. And that again is something the admin nodes would usually control. So depending upon the level of KYC or know your customer data, the blockchain administrators decide whom to give what level of permissions. And based on that, again, that's something the admin nodes do. And we are going to go deeper into this concept of all the permissions. Then we could have validator or mining nodes. So, for example, everybody doesn't need to mine Bitcoin to run a Bitcoin node. Some people could just run data archival nodes. Some could run actual mining nodes where you are competing in the mining process. And of course, that costs a huge amount of electricity, and definitely there's a cost to it. But you could win a reward by getting some free Bitcoins every time you mine a block, or you could even get some kind of transaction fee. If it was a private blockchain, there would be data nodes. Or if you look at an example of Ethereum, which is now a proof of stake, so they also have validator nodes. So these are another category of nodes. Then there could be some nodes which are running the blockchain explorer. So that's the place where all transactions are visible in a web interface. You don't even need to log in. So there could be somebody who runs nodes. On that node, he's also running this software called an explorer, and then anybody can go to that URL or that website and see all the transactions. So that's another kind of thing that could happen. Then there could be enterprises. So here, if you look at this diagram right on top, so I made these three. So I'm presuming, one is a company, one is a bank, and they are connecting to the blockchain. So they have their own internal network where their internal servers are running. So suppose it's a bank. Now that bank already has its own network. Customers can log in, they can do various transactions. Customers may be able to download mobile apps, and through the app, they are communicating with the bank. Now the bank could connect this internal network or their app to the blockchain network or a blockchain node through the API layer. So the bank doesn't have to make a new software. Their existing mobile app can connect through API to the node, and the customers can now get an additional service. So where today the customer, let's say, goes to the ATM and he can withdraw cash, he can deposit the check, etc. Now imagine the customer may also be able to buy tokenized assets. So the bank has tied up with some blockchain network where assets are being tokenized. Bank connects that API to its ATMs or to its mobile apps, and the customer, without having to bother about the technology, can quickly buy and sell tokenized assets also. So banks, companies, all of them can connect to the blockchain network using these APIs. Let me know if there are any questions. Yes, I can see a bunch of questions. Give me a second. Okay. So far I'm hoping everything's been very clear. Now let me take some questions. Yes. So what you're trying to say is that what is architecture when we talk about blockchain, right? So, like, try to consider this like a building. So when you're making a building, the architect's job is to check the soil, whether it is strong enough to hold the building. Then they make sure there are so many different agents or agencies who come into the picture. Someone does RCC structure, someone makes the building, someone puts the glass, someone does plumbing, electrical, all those things. The architect's job is kind of to make the whole big picture. Similarly, when we talk about blockchain architecture, we're talking about the big picture. So as a blockchain architect, a client would come to me and say, this is what we want to achieve. Now, it is my job to advise them that to achieve this, should they firstly create their own blockchain using one of the existing platforms or frameworks, or should they connect to an existing blockchain like Ethereum, for example? Then what kind of applications should be built, how they should be built, what kind of technology frameworks should be used, how they should connect to the chain, how nodes would run. So that entire picture is what a blockchain architect does. So when we say architecture in blockchain, it's kind of the diagram that you see right now in front of you, the whole big picture, and then you keep zooming into different areas and more detail comes in. So I hope that made sense. We take another question. To be a blockchain engineer, should we know front end like React also? If not, what are the technologies we need to know? So that's a good question. So no, you don't need to know front end like React, because that's not really going to be your job. That is going to be a front end or developer's job. You basically need to understand how to set up different chains. Now today there are more than 100 blockchains which are there. So obviously it's not going to be practical for anyone to learn all 100 of them. So I'm going to teach you some of the basic ones, and then as required, you will be able to go and learn more. And you are responsible, or you're going to be responsible for running this network, running the nodes, making sure they are optimized, making sure they are secured. That's primarily going to be your job. Okay, another question is, why blockchain only and not any other technology? Well, I'm not really sure what you mean by that. I mean, blockchain is another technology. It's got some use cases for which it's perfect, and there are other use cases for which you would use other things. So whether you're using blockchain or not depends upon the use case. What is it that you're trying to build? Although I'll be honest with you, in my experience, many people use blockchain for use cases which are not blockchain use cases. But then that's their choice, right? Another interesting question. Data archival nodes, do they capture the actual data and move to different storage? No, so they're going to keep that with themselves. You don't necessarily need to move that somewhere else. You would keep it in the node. So that would be the job of the, say, the archival node to keep all the data. Let me take another question. Any entry in the ledger has to be validated by majority nodes. In case of a private network, is the validation only done by admin nodes? Very good question. So it is not just in case of permission blockchains or private blockchains, right? So even when we look at Ethereum, you and I could be just users. So we could be running nodes, but we are not participating in the staking process, because to participate in that staking or validation process, you need to lock a certain number of tokens. So if I'm not mistaken, for ETH right now, it's 32 ETH you need to lock in. In terms of Binance Smart Chain, millions of dollars worth of BNB needs to be locked in. So most people are not going to do that. We are running nodes because maybe we use it for our own business. So in that scenario, we are not part of the validation or the mining. We are only going to be using it. So it is not only in private networks, it is also in public networks like Bitcoin, like Ethereum, like Binance Chain, where you could participate in the network, do your business, but not be part of the validation or the consensus. I hope that part is clear to you. Let me see another question. Uh, Layer 1 is a protocol itself like Bitcoin, Solana. Layer 2 is developed on top of layer. No, not exactly. There is a framework, so you could go to the GitHub and download Bitcoin Core and run it on your own, or you could run it on a node and connect to the Bitcoin network. That is layer 1. Layer 1 is the blockchain which is running on its own, capable of handling consensus. Then there is layer 2, where consensus is not happening. Consensus happens in layer 1. Layer 2 comes in for specialized features like increasing speed, reducing cost. And layer 0 is something you use to spin up layer 1. So the most important is layer 1. Hope that's clear. Another question is, Etherscan an example of blockchain explorer? Yes, you're right. It is. Somebody says, awesome, enjoying. Nice to hear that. Okay. Want to know about archive nodes. So in the playbook, I have explained all these different types of nodes. So don't worry, you can read that and you will understand. Now let me take another. Web3 blockchain will replace Web2 or both are different? That's a very good question. So again, there is this lot of hype around Web3. In fact, some people talk about Web5 also now. Those are just, I would say, a lot of hype. Basically, when people try to say Web3 is they're talking about connecting to the blockchain or using things like decentralized storage like IPFS. Now, what I want you to remember, blockchain is not going to replace Web2. Web2 is not going to replace blockchain. They are going to work together. So, like, people say we should have decentralized social media networks. Now, I want you guys to tell me, does it actually make sense to you? Like Instagram, YouTube, all of these are centralized social media. Now, people say using blockchain, we will be able to run decentralized social media networks. I don't think that makes any sense because do you ever realize what costs have to be incurred to store all the data in a social media platform? Right now, I am streaming this video to you, it would be MBs. Who's paying for it? We are not paying for it. So Google pays for it. Similarly, every photo you upload, video you upload, text you upload, somebody is paying the cost. Now, if you decide to make it decentralized, you and I will have to pay for it, and I don't think we are going to. Most people I know don't even pay the few dollars to have a YouTube premium subscription. Do you want people or do you expect people to pay hundreds of dollars a month to run the data storage on a decentralized blockchain? Absolutely not. It just doesn't make any sense. So no, Web2 will continue. Web3 has its own this thing, and they will all live together. They all have their own use cases, right? Uh, Let me take another question here. How the cryptocurrency's exchange rate gets determined with respect to fiat currency? So usually this is happening on the basis of demand and supply. So if a lot of people want to sell at a particular time, the price goes down. A lot of people want to buy, price goes up. Another factor that comes into play is liquidity. Certain cryptos have low liquidity, certain have higher. But what we've got to remember is ultimately there is a blockchain, let's say Bitcoin. Actual transactions happen there. The crypto exchange connects to the Bitcoin, right, to the Bitcoin network. But all crypto exchange transactions do not happen on the blockchain, which is why we say not your keys, not your coins. So when you use a centralized crypto exchange, you're not using your own keys anymore. You're using a username password, but the crypto exchange has its own addresses and keys, and they move data or they move the coins on the blockchain. So the pricing doesn't come from the blockchain. The pricing comes from the order book of that centralized crypto exchange. Depending upon the buy sell orders, the price can keep moving up and down. The transactions happen in their private database, and from time to time, they may push it onto the chain. So it's a completely different structure. Somebody wants to know what is the future of blockchain. So I think the number one use case in the future is tokenization of real world assets. That's the reason my project hybrid finance blockchain focuses only on that. So we are looking at, for example, carbon credits, aviation assets like planes and helicopters and drones, real estate, ships, any kind of real world asset being tokenized. I think that is going to be the number one future use case. Let me see another one. Does a blockchain architect write the new consensus algorithm from scratch? No, that's not something we do. That is something that a developer would do, and it's a very high-end job to write new consensus algorithm. There are about 70 plus consensus algorithms, although some of them are very popular, the rest of them are not really that popularly used. If I want to become a blockchain developer, do I need to start okay. So if you want to become a blockchain developer, well, this may not be the right course for you. I would say in that case, you would probably start off with smart contracts. So learn Solidity. Marlow is another very interesting smart contract language, but it's still not gone on mainnet in Cardano. So as of today, I would strongly recommend Solidity would be the right place for you to start. And then API also is another thing that you would need to learn. Let me take another question. If I want to become a blockchain engineer, do I need to start from developer? Oh, no, you don't need to. So blockchain engineer, blockchain developer, slightly different roles. So you don't need to be a developer to become a blockchain engineer. Uh, what are the most what are the most possible things to learn to become a blockchain engineer? Well, that's what this course is all about. So once you read the playbook, you're going to kind of understand what you need to know, and then we'll do the practicals. And By the end of this course, you should be good enough to actually work as a blockchain engineer. That's what I'm going to try to do. Uh, CBDC framework. Okay, let's take that question. CBDC framework is being developed by RBI for e-rupee. Can we say that as a stable coin for INR, such as Tether for USDT? And what would be the okay? First of all, blockchains are not necessary for CBDC. In fact, honestly speaking, I believe CBDC should not run on blockchain because there's only one entity running the CBDC, which is the central bank of the country, like Reserve Bank. They don't need to use blockchain. They can use any other technology, and I would recommend that they actually use some other technology and not blockchain for it. Then, can we compare USDT to CBDC? In some ways, yes. But what we got to understand is, like, some of you may be wondering that why do we even need CBDC? After all, even today, our money is in electronic form, right? So on your phone you would be having your wallets, and you keep your money in electronic form. But what you've got to remember is that money is in the private database of banks. So when I transfer to you or you transfer to me, money moves from the private database of one bank to the private database of another. The central bank is not part of this picture, so it doesn't know what's happening. When it wants to know someone's transactions or the court wants to know, they have to request the banks for the data. CBDC, on the other hand, would not require banks anymore. CBDC would be issued by the central bank. It would directly give addresses or accounts or wallets to individuals in the country like you and me, and the central bank would be able to watch all transactions. So CBDC is slightly different from a tether kind of a situation where there's a private entity holding dollar in its bank and issuing something on a blockchain. CBDC is issued by the creator of the money itself. So that's kind of the difference. I hope that made sense to you. Someone says he's a student from DACO. Hi, nice to connect with you after so many years. Hope you're doing great. Uh, can you refer good channel to learn blockchain development? Sure. I mean, you could just Google around, or you could go on YouTube. You'll find a lot of such ones there. Is there a blockchain group everyone can join? Yes. So when you download the blockchain engineering playbook, you have the 3 groups that I'm running for this course. So definitely join those. But more importantly, if you want to have discussions with each other, then join the LinkedIn group. Let me know if there are any other questions you have. So otherwise, we are kind of at the end of today's. So my purpose today was to introduce you to the course. Let me just check I've not missed something. Okay, so I introduced you to the course, to the playbook. Then I've also mentioned to you why blockchains are called internets of value. Then I explained to you what conceptually a node is and what a blockchain network is. Now I'm going to give you some homework. So you're going to read the first chapter of the playbook, which is on blockchain basics. Then I've made a video which is understanding the Bitcoin white paper. So if blockchain was a religion, Bitcoin would be its Bible, you could say, right? So the Bitcoin white paper, concept of blockchain was first created. So it's very important for us to know. So after reading chapter 1, I'm going to share the link with you. It's in the playbook also. You are going to watch this video. It's more than 1 hour. But in that, I go through all the technical concepts of hash, hexadecimals, Merkle trees, proof of work, and how it actually works. So you will go through that video also. So that's your job for the first weekend. I will be posting this on the WhatsApp group of the course as well as on the LinkedIn group that I mentioned to you. So just take it from any one of those places. Uh, where to download the playbook? So as soon as this session is done, I'm going to put the playbook up on the WhatsApp groups as well as on that LinkedIn group that I was mentioning to you. If you guys want, I will just put the LinkedIn group URL also here. So that would be the simplest for you guys to this thing. In the next 15-20 minutes, I will be putting it up. Also, this video that you're watching, it's being live streamed to YouTube. So you can just go there a few minutes later, and below the video also I'll put this link and you can download it from there. Let me take another interesting question. Are tokenizations of assets and NFTs related? Very good question. An NFT is a tokenized asset, but usually when we talk about NFTs, we are talking about digital art NFTs. So, photos of monkeys or frogs. I know a lot of people get angry when I say they are just photos of monkeys and frogs. I'm just trying to give you an example. So usually we say that that photo has certain intellectual property rights with it, and that's what we call as an NFT. But NFTs are much broader word, non-fungible tokens. So when we talk in the world of finance, things are of two types: fungible and non-fungible. So let's say we take electronic money. So right now in your wallet, suppose you have 500 rupees. There is no difference between any of those rupees. All 500 of those rupees are same. So we say they are fungible, exchangeable, or identical to each other. NFT on the other hand is a non-fungible thing. So if we look at a building, it has 10 floors, and on every floor there is one house. No two houses are identical, even though their size may be the same. The value changes depending upon the furniture inside, depending upon which floor. Higher floors may be costlier. So we say those flats or apartments in a building are non fungible, they are not identical, but fiat currencies are fungible. So that's the difference between fungible and non fungible. I hope that's to you guys. Another question. How to implement CBDC in real-time applications as it is a closed blockchain? So it's still early. We don't even know whether it's going to be on a chain. In due time, the government will open up the APIs for people to build on. It's right now at a pilot stage. Does the course teach how to draft smart contracts from a lawyer perspective? No, we don't get into smart contracts at all. But if you're interested, I actually do have an online free course on smart contracts also. So if you guys are interested in doing that, you'll find all the videos and all in my the blockchain blog, and the link is there in the playbook. You can take it from there. So I don't think, yeah, I don't think there are any other questions right now. So awesome. I'll post your homework. So tomorrow we will not have a class because I have given you enough homework. The book you're going to read is more than 100 pages, but for chapter one, it's about 50 odd pages. The video you're going to watch is about 1.5 hours. So for this weekend, that's your main work. And then next weekend onwards, we'll have regular classes and we are going to move a lot into practicals. So it is very, very important to make sure you complete your homework in time. Otherwise, you will not be able to follow the practical. Uh, okay. Someone says the blockchain link is not working. That's why I've given three, because if two groups are full, you can try out the third one, right? What is the future of privacy coins? Yeah, good question. So when we talk about privacy coins, I think they're getting into a lot of trouble because they are very easy to misuse for things like money laundering. So, for example, Monero or Zcash. So some countries are banning them. So, for example, I think Dubai was one of the first to ban them. And yes, while I'm a big fan of them from a technology point of view, because they can be misused in a big way, yes, they may be in trouble. But the technology that they run on is absolutely amazing. That is, even though it's blockchain, it is not transparent. And actually, you can have a lot of privacy into it. But I think they're heading for a lot of legal trouble. How DeFi uses blockchain? Very good question. So when we say DeFi, we mean decentralized finance. So in fact, the definition of that is when you run financial use cases on a blockchain, especially public blockchains, then you call it DeFi. What I work on is the area called hi-fi, which is hybrid finance, where regulated entities like banks are using blockchain but with full legal compliance. So we can say three areas: centralized finance, which is where the conventional banking happens; decentralized finance, which is where there is no regulatory compliance and it's completely blockchain based; and then in the middle, connecting the two, is hybrid finance, where we take the best of both worlds. Uh, Okay, awesome. So I'll see you guys next week. And in the meanwhile, make sure you do your homework on time. Bye bye and have a nice weekend.